Okay, so here we have one of the more difficult trig substitution cases where you have to first complete the square on what's inside the square root. And so the first thing we're going to do, we're going to grab this x squared minus 4x plus 8, and then we're going to complete the square on this. So remember that what you do is you grab the term with degree 1, you divide that constant by 2, and then you square it. So 4 divided by 2 is 2, square that is 4, and then you're going to add that 4, and then you're going to subtract that 4 as well. Okay. And then the plus 8 is going to stay there. So then this x squared minus 4x plus 4, that's a perfect square. So that's just going to be x minus 2 squared. And then plus, when you combine the 8 and the 4, you get 4. So then you do a substitution. You go, okay, well, let's let u be x minus 2. And then du is going to equal to 1 dx. So then what you get is this is going to equal to the integral. Dx is going to be du. And then this right here is going to be the square root of, instead of x squared minus 4x plus 8, you're going to use u squared plus 4. So this is du over the square root of u squared plus 4. And so see, now it's easy to recognize as a trig substitution case where you would do let u be, instead of x, it's u this time, 2 tangent theta. Then du is 2 secant squared theta. And then you, just like normal, at this point it's exactly the same as you normally do trig substitution, except that you have u instead of x, but that's okay. So the square root of u squared plus 4 is the square root of 2 tangent squared theta. Sorry, not 2, 4. Erase that. Forgot to square it. 4 tangent squared plus 4. And if you factor out the 4 and get the square root of that, that's 2 square root of tangent squared plus 1. This is equal to secant theta. Okay. So then this integral right here is going to equal to the integral. Du is 2 secant squared theta d theta. I forgot the d theta over here again. Sorry. And then over 2 secant theta. That's from this one right here. Okay. And then we simplify this a little bit. We would get the integral of secant theta d theta. And we remember this from before. This is equal to the natural log of the absolute value of secant theta plus tangent theta plus c. Okay. And then remember, we have to go back to the original variable. So we are going to use our, so let me put a little divider here. Okay, so we know that u is equal to 2 tangent theta, so u over 2 is equal to tangent theta. Okay, so that one's easy. I can change this one for u over 2, and then, but using that, we do our right triangle. We have theta here, and so since tangent of theta is u over 2, that means this one would be u, this one would be 2, and then the hypotenuse is going to be u squared plus 4. Okay, so that means secant is going to equal to the square root of u squared plus 4 over 2. Okay, so then this is going to equal to natural log the absolute value square root of u squared plus 4 over 2 plus u over 2 plus c. Okay, but then we have to go back to what u is equal to. Remember that u is equal to x minus 2, so we need to substitute that back in there. So then this is going to equal to the natural log. Let me get a little more space here. Absolute value square root of x minus 2 squared plus 4 over 2 plus x minus 2 over 2 plus c. And that's it.